Great. Okay, hi everyone. My name is Bo Huang. It's an honor to be here today to talk to you guys about subjects I'm very passionate about. A little bit background about me. It's like my background is in computer graphics and games. Some of the things I do include, for example, I do things like atmospheric scattering, map visualization, ray tracing, games, the material simulation, and everything that's like, say, material capture and photogrammetry, architecture, etc. Some of the companies I worked for in the past include, say, X-Rite, which is a color science company, which I was engineering scientist. In other companies, I was mostly developing games. Okay, so today I'm going to be talking about data. I mean, everyone here is very knowledgeable about data, so I won't go into too much detail. But as to summarize, there is basically a lot of data in our current world right now, and most of them are invisible. And a lot of them are generated by, say, IoT data, your typical data from your cloud sources, and etc. And those data are spatial, temporal, and scattered all over the world. And all of them are in different formats and different organization structures. So you may not be able to work with all of them. But they need to be really displayed to be meaningful to people. I mean, otherwise you don't know what they are. So one thing that I think the best is to start with a demo of sort. So to let people know what is going on with data that I'm working with. So here is I'm using the Unity game engine, and I'm going to show you here is a section of San Francisco. Well, it's very slow right now because obviously there's a lot of data. But we could zoom in to. Oh, it's slow because I'm not plugged into power. So the laptop goes into the low CPU cycle mode. Okay, but so you have to kind of pretend that it's in real time because usually it is. You just have to believe me.
Maybe you can tweak the power mode to force it to the maximum.
Zoom to the maximum, you said?
No, the power mode, the control panel's setting. Maybe you could change it on battery.
Okay.
Or we could plug it in.
How about this? I mean, I could continue with the talk, and at the end, we'll plug it in and see how it works like.
Excellent.
Okay, so you got a rough preview, but I think one thing to talk about is like, we have all sorts of data, and in this specific case, it's map and geology. I mean, geoscience related. No, not geoscience. Geodata related. And a lot of this data is we want to display them in real time, and for bandwidth considerations that we need a compact data format and some infrastructure to catalog, modify, delete, and of course retrieve those kind of data for all kinds of devices. So what's the data source? I mean, this talk is mostly about mapping data. So OpenStreetMap is a very obvious choice. OpenStreetMap, for those who don't know, is an open source data format, data collection that's crowdsourced by users all over the world, in which everybody crowdsource mapping data and contribute to this master source. So unlike Google's or others, which is closed. So what that means, you could download the data and do whatever you want with them. So in our case, we retrieve them from the data and make a 3D world to play around with. So some applications include just like visualization in your typical virtual reality settings. For example, here is an image of when we were demoing at the NVIDIA's GPU technology conference. Here's the booth, and we were demoing this 3D world in a HTC Vive setting. Okay. For this part, I'm going to be relatively simple because like you could look it up online. You know, it has a long history, over 10 years, a lot of users. You can modify, download, and if you go to the website, it approximately looks like this. Looks like your typical map, and you can zoom in, out. But if you follow the pertinent links, you're going to be able to download the data sources, and those data sources are usually in XML format, so you could parse. I mean, other data formats are also available. So why is it good? Because like there are lots of buildings, lots of roads, lots of amenities. Amenities being, say, restaurants, your local bars, or your local water fountain, parks in the bench, etc. And as you could also add your own stuff to it. I mean, there are lots of data you could input in. I mean, as long as you agree to certain standardizations that's agreed upon by the community. And of course, like say IoT setting, like if you are able to get your IoT devices onto this map, then you automatically have an infrastructural platform for your device to register itself, and also discover other IoT devices in its proximity, or in your local neighborhood or the city. Some examples I think I mentioned about just a lot of different things that you could imagine from our real world. And here are some, say, rendering of what it looks like from our San Francisco data source. Now, we have this data, and we're looking for areas of application. Like say one area is like it's your IoT devices. It's like why do you want to, talk with your IoT devices? Because like internet connected, that's the trend to go. So in terms of say data set, I think that this is talking about that OSM data is reversible, it's moderated by the community, and you should have fairly accurate data. And it's constantly being improved. How to add your devices or how to add your data, you just sign in, and there are editors that you could learn to use and add your data. And how to modify, again there are APIs and editors all available. And other devices and APIs. So say, for example, the overpass API is a very useful one that you could query in real time a particular section of data that you are of some city squares. So let's talk about some use case. Like say, for example, smart building is an obvious thing because like increasingly we're having a lot of different IoT devices and just devices in general available, from your robots, your vacuum cleaners, or your security cameras, etc. All of them need to know what and where they are. And of course, I mean they probably will increasingly have some functionality of knowing that using say computer vision techniques to know where they are, what kind of obstacles that they're facing, but for the most part, they're limited to very high-end devices, which are now available to us now. But so one use case of using this mapping data, especially in a 3D fashion, is that you could use those data and create a 3D world in which the devices, your vacuum cleaners and the robots, they could collide against, or know where is a piece of wall, where's like the staircase, so that they don't make a fool of themselves. Another use case is your, say, disaster. I mean, OpenStreetMap is already used by volunteers and professional rescuers to rescue people. And one thing they do is like say, because like when disasters strike, it's the terrain and geography changes. Like so, rescue workers need to know accurate knowledge of what is the most up-to-date map condition. For example, in your first 72 hours of disaster, mobile devices are very valuable because for the most part, they still maintain a charge for people trapped in rubbles, for example, so that it's relevant to have those to detect where the devices are. So that's where the previously mentioned IoT device networking and infrastructure comes into play. So if you are a rescuer and you're equipped with devices in a virtual map to know, hey, here's this floor or this subway, and I need to go down, and there are people trapped inside. Whereas your traditional map is a 2D flat plane, and you're not going to be able to do so much, especially say people who are trapped under the subway. Then of course for the post-construction stage for disasters, you'll be able to track, say, oh, where's your say water leaks, where's your I don't know, nuclear hazard for those extreme cases, and you can synchronize with satellite imagery sources. Another use case is with drones. I mean, drones are increasingly ubiquitous nowadays, but most of them are not so smart. Like, say, they require users, the controller, to control where they fly to. So, I mean, we would use the maps to make the drones smarter. Like, say, the drones will be able to store, say, map of the location where they are flying to, including, in this case, 3D maps, multi-level stories of buildings, so that they know approximately where they are. Say, where's in how many meters they will be able to collide. Well, they will hit a wall and destroy themselves. Now, of course, they will supplement the accuracy with their own sensors when they get to that technology level. And another thing I want to mention is, like, say, why do you now want to use Google Earth or other similar mapping technologies? Because for Google Earth, there's a lot of visual noise. I mean, there are cars, there are people, there are trees. They're all scanned and baked inside the map, even though it's a 3D structure. And for say multi-level stories, for many buildings, you're not able to go inside. And of course, another downside is that it's updated once every few months, perhaps. And maybe for hotspots, it's updated quicker. But compared to your open source maps, it's much slower. Oh, and another thing I should mention is that for Google Earth, you're also limited to what your satellite could see. So if you are so your subways and underground, say water pipelines or whatnot, will not be seen by the satellite, and you are missing those type of information. Whereas with open mapping data, it will be increasingly available. Now, I think this is talking about, this slide is talking about what I mentioned earlier, that drones are not smart. They need human assistance, so all to deduce like what is around them. So with, and especially with, say, computer vision, it's modified, or it's impacted by the lighting conditions. For example, in this current room, there's a very bright light shining at my face right now. If you have a drone, like even if it's very smart and using computer vision to detect where is where's the next wall, but the light, the strong light will influence, will be a bright splotchy spot for the computer vision camera, and so that the drone essentially what the drone sees is a very overexposed imagery that it may not be able to deduce. What is, say, where the light is, compared to, say, if the light is were to be off and not emitting any photographic sources. Yeah, so this is also the same thing. Like, so with these kind of data sources that we increasingly have access to and are able to make an interactive use of, we could create 3D meshes to help with collision detection, and you could plan a custom zigzagging path of where the drone is to fly to, and you have very high levels of confidence that you'll be able to succeed. Now, finally, I think I'll show another few sets of pictures. This is a Stanford, Connecticut, okay, where we had in which we were part of a hackathon that was held over there for smart cities, in which the Stanford supplied to their smart city sources, which is like because like Stanford is a high tech city just like San Francisco, and it's very keen on presenting itself as high tech, data friendly, and also smart. Hence, we use their data source and constructed 3D simulations. I mean 3D models, so that it will be usable for the hackathon. Okay, and I think I'll just say that for that hackathon, the data sources, basically the 3D models, are already available on GitHub. We put it online here, so you go to GitHub/SenseEarth. You will be able to download all kinds of data source. I mean, the 3D models. I mean, they're in OBJ format, which is a very standard 3D format. So you'll be able to use them in your typical computer, your game engines or WebGL. Okay, that concludes my talk. Here's my contact information, and I will be happy to assist if you have questions.